In this video we are going to discuss about mod n counter. This is also called as modulo. So mod represent modulo. So the procedure to design it is nothing but a synchronous counter. Okay, the procedure for designing this counter is first step is finding the number of flip-flops in order to implement this counter. So the formula is 2 power n greater than or equal to n. Here this n represent number of flip-flops and small n represent number of states, okay, or mod number. For example, if it is a mod 5, mod 5 n value is 5. Okay, so second step is write the excitation table table for the flip-flops which we are going to implement. Okay, next determine the transition table. Using the given condition and the excitation of the flip-flops, and next one is simplify the expression for the flip-flop using K-map. So use K-map for simplification. So last one is implement the logic diagram for the expression. So let us discuss the first problem. They are asking design a synchronous mod of 6 counters. Okay, mod 6 counter and implement it using JK flip-flop. Okay, so here for the first step is 2 power n is greater than or equal to n. So here 2 power n is greater than or equal to 6. N value is 6. So what is the value of n? So n must be, if it is 2, 4 is not greater than or equal to 6. So the n value should be n value should be 3. So what it represent, so here the n represent number of flip-flops. So here I am going to use 3 flip-flops. Okay, 3 JK flip-flops. Therefore 3 JK flip-flop is necessary in order to implement this mod 6 counters. Okay, so if I want to draw the state diagram, it looks like this: 0 0 2 0 1 1, then 0 1 0 0 1 1 1 2 3 4 5 and 6. Okay, so next step is excitation table for JK flip flops. So step 2 is excitation table for JK flip flop. So Q plus JK 0 0 0 1 1 0 1 1, that is 0 1 XX XX 1 0. So this is the excitation table. So third step is transition table, right? So you have to write the present state. So since we are using 3 flip-flops, I can write it as QA, QB and QC. What is the next state? Next state. So next state is QA plus, QB plus and QC plus. Okay. So we are using a JK flip-flop. So JA, KA, JB, KB, JC, KC. Okay, this is a flip-flop. Okay, so it starts from, so I have already drawn the state diagram. So this is your state diagram. Since it is 6, I have drawn this 6 circle. Okay, and if the present state is now 0 0 0 0, the next state is 0 0 1. Okay, so if the present state is 0 0 0, the next state is 0 0 1. So if the present state is 0 0 1, then the next state is 0 1 0. So if the present state is 0 1 0, the next state is 0 1 1. If the present state is 0 1 1, the next state is 1 0 0. The present state is 1 0 0, the next state is 1 0 1. Okay, if the present state is 1 0 1, the next state is 0 0 0. Okay, so now I am going to compare 0 and 0. Okay, so I have already done, this is QA, Q plus. So what is the value of 0? 0 0 0 x. So 0 0 is 0 0 is 0 x. This is also 0 x, right? And what is 0 1? 0 1 is 1 x. So this is 0 x, 0 x. 0 1 is 1 x, and 1 1 is x 0. This is x1. Okay, so what is 0 1? 0 1 is you have to compare QB and QB plus, and you have to write it in JB KB. That is 1x. So 0 0 is 0x, 0x. 0 1 is 1x. So here also you have 1x. Next for 1 1 it is x0. So for 1 1 it is x0. For 1 0, for 1 0 it is x1. So for 1 0 it is x1. For 1 0 it is x1. x1. For 1 0 it is x1. Okay, so what is the next step? Next step is you need to find the value of using the k map. You have to simplify the equation, right? The step 4 is simplification using k map. So what is JA? JA of QA, QB, QC. JA of QA, QB, QC is equal to this is 0 for so instead of writing like this, you can better implement so first for JA, so okay, K map for JA. So since it is 3 variable, you can use this alone. Okay. QA, QB, QC 0 1 0 0 0 1 1 1 1 0. So for 0 1 1, J is 1. For 0 1 1, J is 1, and for 1 0 0 and 1 0 1 it is 6. 1 0 0 and 1 0 1 it is 6. Okay, so if I group, I can group only this one. So what is the value of JA? JA is equal to QA bar QB QC. Okay, so next I have to go for the K map for KA. QA, QB, QC. So for 1 0 1 it is 1. So 1 0 1 is here, and for 0 to 3 it is x. Okay, so 0 to 3 it is x. So I can group this one. So if I group this one, I find the value of Ka is equal to, since it is 0 1, QB bar QC. But before this you have to write the values for what happened to um, one 1 0 and 1 1 1. So what is the value of 1 1 1 0? So we don't know the value, we don't know where it will goes, right? So it is x x x now. Someone change, I have made a mistake. Okay, so I have to substitute for this one as x. So if I group this one, I will get QB QC. J is equal to QB QC. and similarly for this is xx, so I can group this. If I group this, I will get ka is equal to uc. Now let me go for jb. Okay, so this is always xx now. So you substitute for jb 01xx 00 01xx 00. So I can group this one. So if I group this one, it will be qa. So jb is equal to qa bar qc. Now let me go for kb. So for kb it is double x 101 double x 01, and this is always 11. So next for jb it is everything is x. So if I group this one, I will get kb equal to qc. Next kmf for jc. So what is the value? 1x 1x 1x. Okay, so 1x 1x 1x. So jc value is equal to 1 because I can group all this value. Okay, so since all the values are 1, you can write it as jc is equal to 1. So next kmf for kc. So what is the value? x1 x1 x1. Okay, so x1 x1 x1. So this is also, I group all this one, I will get kc is equal to 1. So now you substitute all this value. Okay, so you draw jk flip flop, jk, since it is a, so this is a flip flop and this is b flip flop. Okay, and this is c. So you know the value of j and c, right? That is 1 1, and you have a common clock for all the, since it is a synchronous counter. The clock value is same for all the flip flops. So what is JA? JA is equal to QB QC and KA is equal to QC. So KA is QC, KA and KB is equal to QC. Okay. And what is BC? Okay, J is equal to QB QC. So it has to be connected here, QB and QC. Okay, so likewise what is JB? JB is QA bar QC. Okay, this is QA bar and this is QC. This is your QC. So I hope this video is useful for you.